Hello guys, and welcome to this tutorial on parallel and series connections of resistances. So in this example, it is a problem from the text, and it asks to find the total resistance, the total resistance of these things seen by this source. Okay? In other words, we need to make a new circuit, or to draw the equivalent circuit of this. So this resistance, this one, represent the whole set of these resistances connected together. Okay, now this is a typical and straightforward problem. The only thing here that you should pay attention is not to miss some things, because there are many connections, as you see. One way to do that is actually to do it by head, and in your head, to say, okay, these two resistances are in series, their total is 30, that total is parallel to this 60, that 60 and 30 in their parallel connection give us 20, and so on. But this approach comes with experience. You have to do a lot of problems first, then you can do it like that. However, the safer way is to redraw the circuit. So we will redraw the circuit, okay, and go according to the connection of these resistances. So we have the source. Here is the source. There is 40 ohms parallel to the source. Here it is. Then there is that 20 and this 60, right? So this is the 20 and this is the 60 from those up. Then we have now this 50 ohms. Now this 50 ohms connected from this node here, which is this node here, to this node here, that is this node here. Okay, so we will pull up this node up to here, that like taking this wire or branch and pull it back to here. Okay, and connect the 50 ohms. So this whole thing, maybe I can take another color just to emphasize the idea. This whole thing here is actually this thing here. Okay, now so we are done with this 50, with this 60, with this 20, with this 40. Now we have this 20, which comes after the node to the right. So here it is. This is the 20. And then we have a 70, which is coming from the node parallel to this one, that is like this. Actually, not exactly parallel, rather coming from this node, which is here, to this node of the 20 that is here. Okay, so we are done with this one, we are done with this one. That leaves a 30 to the right, here it is, and a 60 from here to here, and this 18 and the 12 are there. So this is 18, this is 12, this is 60, this is 30, this is 75, this is the 20, and this is the 50. That is now our circuit. Okay, so now you can go and say, all right, I have these two are in series because they are connected at this point, so their total is 30, and we will put it here. Here is 30. Now that means 30, 60, 30, 75, nothing. Here there is this thing. Here is the 20, 50, and the two in parallel. Okay, the 40 and the current source. This guy is 30 now, so we we reduced this one to this one. Now if I continue like this, it will take a lot of time, so I will not go and draw each step. Rather, I will draw the result of a couple of steps. So we have 30 and 60 in parallel. This one is 60, which is this one. From the original circuit is this one. So 30 and 60 are in parallel. In parallel, we can find it either by the reciprocal of the summation of the reciprocals, or we can multiply. If it is two resistances in parallel, we can multiply them 30 times 60 over their total, that is 30 plus 60, and that's 60, that's 90, and this gives us 20 ohms. So now we reduced this part into 20 ohms. Now we have this 20 is in series. You can imagine this, it is 20, and now it is in series with this one here. So this guy reduced to 30, with this both reduced 20, it is now in series with this 30. So we have here 20 and here we have 30. They are in series, so their total is going to be 50. That means if I do it here, we are done with this, right? And done with this 30 because it is there. Okay, I have to get used to these tablets. Sorry about this. So now we have this 50 here, which comes from these two in series. 50 and 75 in parallel. 50 times 75 over their total 125. That gives us what? 50 over 20, that is 10, 25, 3, so it is 30 ohms. And this actually confirms the idea that is the total of two parallel resistances. Total of two parallel resistances is less than the smallest one. So 30 is less than 50 and 75. Okay, so now this part is 30. So maybe I can remove it. And say it is equal to 30. Again, now we have 50 here because those two together are in series. So these two reduce to 50. Here is that 50. These two together, 50 and 50, reduce to 25. 50 times 50 over 100, that is 25. Okay, so we can remove this. That is too much. Okay, just remove this one. Maybe this one. Okay, as I said, I have to get used to these things. Alright, so this is 25. Now here, a common mistake that many of you guys are going to make is actually saying, okay, this is 60, this is 60 and it is in series with this 25. That is not correct. Okay, if you remember, the idea of series is this and this are in series, provided that there is nothing in the node in between. If there is anything in the node between, whether a resistance or a source or anything, so these two are not in series. Okay, many of you make this mistake in the tests or exams or in solving problems, assuming that that this resistance, the 60, sorry, so this resistance, the 60, this one and this one are in series. They are not in series. Or this 40 and this 60 in series. They are not in series because there is something connected to the node in between them. If there is something in between them connected to the node, then they are not in series. You have to find out another way to find the total, but these two are not in series. Okay, so first things are first. Here we have these two the 20 and the 60 are in parallel for sure. So if we reduce them to something in parallel, this will become this thing. So these two will reduce to one resistance, and that resistance is connected to this 25, and there is nothing in between them here. So the equivalent of these two resistances and the 25 are in series, but not any of those alone with the 25. Please pay attention for this because it happens a lot that you make that mistake. The 20 and 60 in parallel, they give us 1200 over 80, and that is 15, I guess, right? Okay, so these two give us 15 ohms. Alright, and that means we have 25 here, we have 15 here, and we have 40 here, like that. Now, again, the same issue. We cannot say that this 40 is in series with this 15, or this 40 is in series with the source or something. This 40 is alone by itself because it is connected from both terminals to a third terminal of another component or element. But these two guys, these two are in series, so they are 40. 40 and 40 in parallel, the total is 20. That means this circuit reduces to so our circuit, finally we found the solution. It reduces to a power source of 80 milliamps and a resistor of 20 ohms. This 20 ohms comes from this 15 in series with this 20, that is 40. 40 parallel to 40 gives us 20 ohms. Okay, now the second thing that was asked by the problem is what amount of power delivered by the source. So there are three different equations that can represent power in DC circuits, and I will just write them to remind you. Power equal voltage times current. Power, again, if we express voltage as the current times resistance, that means current square times resistance, and power equal, if we represent current as voltage over resistance, voltage square over resistance. In this circuit we have information about the current and the resistance. That means this is our power. Of course we can find the voltage from the current and the resistance as well, but this is straightforward. 80 milliamps squared times the resistance of 20 ohms, that gives us 6400 times 10 to minus 6, because this milli is 10 to minus, because the milli is 10 to minus 3, times 20. So we have like 3 zeros here, and that is 123 zeros, cancels with 3 zeros, 128 milliwatt. Okay, this is the power delivered by the source. Okay guys, I hope this was useful and helpful. So to summarize, first draw an equivalent circuit, or redraw the circuit given so that you don't make mistakes. After you redraw the circuit, you should make sure that you don't mix elements that are not connected in parallel or series, and we will discuss this in this class. If you have elements that are connected in a delta configuration or a Y configuration or so on. I guess I made a mistake here. This is not correct, so there is no resistance here. Okay, this is the way how to reduce the circuit. So I'm just redrawing the circuit again for you. This is the 20, this is the 75, and from here there is 30, and there is again a line, and the 60, and then there is the 18 and the 12. Okay, redraw the circuit, and then you can solve it. This is it for this example, and see you in another examples and in the class.